Alright, we're continuing on exam review. I hope you had more chance to take a look at these questions. Did you? Okay. So, which question you want to start with?
Can you do 18?
Sure. Alright, multiply two radical expressions. Here's the multiplication. We multiply three guys in front and also inmates in jail. But first, you need to clean up jail, see if anyone can break jail. That's one choice. Or some people first multiply, bring all jail people together in the under the same roof, then let them break prison. Either way is fine, okay? But just pick one and go. So here's our expression. I will first combine everybody under the same roof. Meanwhile, I will also multiply three guys, right? These are out. So 4 times minus 2 is minus 8. And take a really big jail and stuff all these two jail people into the same roof, right? 3 p squared q cubed is the first group. 6 p q squared is the second group. Well, they will combine forces, right? So they will join each other really. These inmates will join forces and make bigger powers and start bribing the guard. What is the guard, by the way? 2. So to break prison you need $2. Let's see. I don't see, I see 3 and 6 looks different. They don't combine powers, but when you think 6 as 3 times 2, they actually share a factor common. So you can couple them and make 3 square out of them. But the 2, this 2 is single. So it will just, I will just keep it like that. 2 is single, but 3 is couple. So guess what's gonna happen? It's gonna go out. But let's first join the others. Oh, p squared and p makes p cubed. But you know what? I won't join them. Because when I combine into p cubed, they will break prison because they have more money than bailout money, right? $2, $3. So they will break prison, but again, 2 of them will break prison and 1 will stay. Again, when you divide 3 by 2, 2 goes into 3 once, and there will be 1 p left. So why don't we leave that p already alone, not combine, and just take this guy directly out right here. Take this guy out, right, like this p, and instead of combining them into p cubed, leave p to the 1 alone. So this red p is still inside. Blue p squared out. I decided to not combine them because they will break anyways to escape prison. Or how about q cubes? I will join them. I mean, you can move this out. This guy is moving out, but there are also people from q cube moving out. You may first join them and make q to the 5th. So what is 5th power divided by 2? 2 of them will go out. 2 times 2 is 4. But 1 will stay in. So there will be 1 q left. 1 q left. But 2 q's out. So 2 q's means q squared out. Q squared 8 and p out. Also 3 is out. So let's move this 3 out as well. By the way, my q's look like 9, but let's put like that. It's not 9, okay? q square 3 8p out 2p q in. This is gone. So let's collect all those three guys, line them up right properly. 3 times 8 is 24, negative sign in front, so it's negative 24 p q squared. And who is left in prison? 2p q. Is this what you got? Okay, this is again one version. Again, one may prefer first saving people from prison then join them. Like this p squared comes out as p. Gone. Q squared splits, two of them comes out as 1q, but there will be 1q remaining because cube has a square and 1. And this guy comes out and p is in. So you may have a better leverage on this question if you bring stuff out already. So 4pq out, 3q in. Only q out here, 6p in. Then we join these again, multiply 3 guys and then inmates. This is just the second method. 4 times minus 2 is minus 8 p cube. Q is pq squared times 3 6 q p. Well, when you break 6, there is 3 and 2. This double 2 also comes out as 3. Gone as 3 because 3 squared comes out as 3. And we have 3 times 8, 24. P q squared, 2pq, same answer, different approach. Your choice. Okay? I just solved it 2 different ways. Alright, next question.
Number 19.
Let me put this in minus 2pq, was that it? Alright, number 19 is again multiplication of radicals, but this time in the first group you have 2 radicals, in the second group you have another pair of radicals, 2 radicals. They are joined together with the subtraction. Subtraction times another subtraction. Alright, how do we go with this one? It's just basic distribution. FOIL. First terms, outside terms, inside terms, and last terms. It's FOIL. Again, first terms is 2 root 5 times root 5. Outside terms 2 root 5 minus 7 root 3. We multiply 3 guys first, minus 14. 2 times 7, this is again O, this is F. I'm doing O. 2 times 7, 14. Root 5 root 3. Inside terms, this is I. Root 3 root 5 with a negative, like negative 1 positive 1. Negative 1 times positive 1 is negative root 3 root 5. and last terms L minus 1 minus 7 makes positive 7, root 3 root 3. Alright, when you have a double, same square root, double, this becomes 5 squared. Under this one radical, this is 5 squared, and you have a square root and square, they cancel. This is 2 times 5, which is 10. When you have two different radicals, you cannot add them, but you can always multiply them. Multiplication is fine. They are not like, but you can still multiply them. You cannot add or subtract them though. We can multiply 5 and 3 and make root 15. Same deal, make root 15. 5 times 3, 15. Here though, double 3 makes 3 square under the radical. Square and square root cancels, and 7 times 3 is 21. Are we done? We're done with multiplications, but rest is combining like terms and simplifying. There are like items here. You see numbers and numbers. So we can combine blue circles as 31. What else is like? Any more like items? Radicals. Radicals are called like if they are the same index radical and same radicand or inmates. So these are same jails with same inmates, 15, 15. So they can be added or subtracted, whatever the sign is. If there is nothing in front, that means it's 1. So you have minus 14 of them here and another minus 1 of them. What is minus 14 add minus 1? Minus how many? 15 in total. Oh, 21 is gone, so this is it. Minus 15 root 15. Okay? No. Negative number and another negative number makes a bigger negative number. Make sense? Alright, next. Pick one.
24.
24. I'm only taking this part, okay? It says, this is called rationalizing the denominator. Why? Why do we need to do that? We do not like seeing radicals in the denominator. When you see them, you need to multiply top and bottom to save that y from that prison. We need to multiply top and bottom so I no longer have prison in the denominator. Okay? So I take that 8 over square root y to the 4th and I need to put something next to it. Well, first clue, they must be same type radicals. So I put 4th radical, 4th index root of something. But what will it be inside? So when these two radicals combine, that y and whatever you put here will combine as well, and they will be all set free. They will have their freedom. What do you need to put here and multiply so they can all have freedom? But the least, most economical choice. Don't say here 1 to the 1, y to the 1 million. Y to the third. Y to the third makes best sense. Because when I join these bottom radicals, I don't care the top. our issue is the bottom. We want to save the bottom, guys. When I join these radicals, y and y cubed becomes, how many y's you have now? 1 here, triple more, 4 of them. And if you have $4 and the guard wants $4, they cancel each other, and you will have only y set free, clear of everything. How about the top then? Top pays the price, top gets the radical, but we are okay. You can have as many radicals as you wish on the top. We know we are not worried about the top. Only the bottom should be clear of radicals. Oh, by the way, you don't have to do any of this in this question. This is just extra I did. They just wanted to know what is coming in this question, right? So we just figured it. Y cubed. Y cubed. You don't have to multiply in this question, but in the next following questions, I think you must. Okay. Okay. Whether it's 26 or 25. This one will require multiplication, but it's kind of easy. This one doesn't require, so I will skip. This one will require, anytime you see rationalize the denominator, you must multiply across and do all the way to the end. So this is the most complicated question of that kind. Do you prefer 28 or something a little bit easier? Which way? 27 or 28? Both? Okay, let's start with 27 then. Whoa, why is it not copying? Okay, now this is a little bit different than what I just explained. This is not a single radical situation. This is a two-term. You have a jail plus some stuff added to. Add more stuff. Or add free guys. No jail situation. Jail plus no jail, or jail minus no jail. So this is a two-term denominator trick. Here, just multiplying by the same jail is not enough here. Because when you're saving this guy, you're going to mess up this one. Because when you pass root 7 to both terms, this will be free. You will save everybody here, but this two will have a jail tail, and it's going to be bad. So just multiplying with one term in this question is not going to work. So what are we going to multiply them with then? We're going to multiply conjugate, yes. Root 7 and 2 repeated, root 7 and 2 with conjugate means take opposite of this sign. It's opposite signs, and please use plenty of parentheses around every pair of terms. Not 4 is single, you don't have to, but every other thing needs a parentheses. And we will multiply across now. 4 root 7 minus 8 is the top. The bottom multiplication is easy. You do not have to do FOIL here. You did FOIL here on this question. This is FOIL because everything was different. All two terms on the left and right different. Here though, you have the same two terms, 7 root 2, 7 2, 7 2. Only the difference is minus and plus. They are called conjugate. We are going to do conjugate multiplication here, which is the difference of two squares only. What two squares? Root 7, and the other number is not negative 2, it's just 2. Just leave out the minus or plus, just take the digits. That minus will transfer here, okay? Alright, you're pretty much done. just do the operation on the denominator. Root 7 squared is just 7. 2 squared is 4. And that's it. You see, you rationalize. Do you see any jail in the denominator anymore? It's called rational denominator, so we are through, we are done. Alright, 28 is similar. It's just a little bit more work. This time we will multiply top and bottom with, so let's put everything in parentheses first. I see two terms. What do you want to multiply both sides with? Tell me. Yeah. Conjugate of the bottom. So it's minus. Plus turns into minus. How about the top? Oh, top will get its own conjugate, right? So you will get conjugate of the top as well. You'll flip the sign in the end of the top. Yeah. No, this is wrong. Do not do that. You don't care about what's on the top. Besides, you cannot multiply top and bottom with separate terms. It's unfair. You need to be fair to the top and bottom. Whatever you're doing onto the bottom, you must repeat the top. So copy what you have on the bottom and multiply the top. Alright, this is gonna be a long FOIL on the top, right? This is a FOIL. First, outside, inside, last. Bottom, however, this is conjugates. It's easy, it's just square difference. Difference of squares of each term. 7 root 6 squared, 7 root 7 squared, that's it. Bottom is easy, top is foiling. Yeah, I don't think I can foil on this short space, but I will foil in the next page and put it here on the top, okay? Or I can do it right underneath. Okay, let's first finish the bottom then. 7 squared root 6 squared will be 49. Root 6 times root 6 will be 6. Minus root 7 times root 7 will be only 7. Again, square and square root always cancels, we got 7. Square and square root cancels, we have 6. But 7, free guy, also doubles. 7 times 7 is 49. Let's FOIL the top. 6 times 7, 42. Root 6 times root 6 is 6. That's F. O. Outside terms. 6 root 7, 6 root 6 and root 7 all multiplied into minus 6 root 42. Minus 6 times minus 1, minus 6, 6 times 7, 42. So you multiply inside of the radicals. 7, now I'm in I, inside. Minus 1 times 7 is minus 7. Root 7 times root 6 is root 42. Now outside terms, minus 1 is plus 1. Minus 1 plus 1. 7, root 7 is just 7. We always, when you FOIL, we combine the middle terms, we combine first and last terms. Always, no exception. That's always true. By the way, 42 times 6 is 252. This is 252. And 7 more to 252 makes 259. These are like 7 apples minus 6. Minus 6 apples minus 7 apple. They combine into minus 13 apples. 6 times 49 is, what is it? 294? Yes. Take away 7 though, 287. Okay? Yeah, that's it. My numbers are ugly. Did you check my work? I hope we did everything right. So minus 13. What was the bottom? 287. Good. Next question. Come on. Please tell me a section and I pick a question. 4. Alright. What is this operation called again? Composition. We need to compose two formulas and evaluate them at -1. Here we are. Alright, it's the same story we did yesterday. We did this with graphs, remember? So this is your passenger or material going into a machine. There is a series of two machines here. -1 is first used in machine M. So it's going to be converted into another material in M. It's going to be transformed in M. So all you need to do is find out the formula of M, enter -1 into it, supply to it, and see what material it turns into, what number it turns into. So I will do that. -1 visits M. Here is M. I'm visiting M as -1 in X. So that means you need to make every X -1 there and compute it. What do you get? -1 cube is -1 times -1 times -1. What is -1 times -1 times -1? First 2 makes +1, and then you multiply again, makes -1 as well, right? Oh, how great is that? -1 entered into the machine and comes out as -1. It looks like the machine did nothing to it. That's fine. I don't care. we still, whatever you got from M, we send it into the next machine. What is the next machine? P machine. So supply the answer, which is -1, into P machine now. Okay? I'm supplying -1 into this machine and see what you get. 1 over this, which is 1 over 2. Oh, we need to say first, yes, there is an answer, I think. A real number, yes. We found a real number, which is 1 over 2. Understood? Alright, let's work on a different question. How do you guys do P, not P, why don't we take M out first? M circle P of -2. So this question gone, clean start, gone, all gone. Just do what I said. Passenger -2 or material -2 is visiting which machine first? Which one? P. So enter -2 in P then. What do you get? 1. Alright. 1 is coming out of P, entering into M. Enter it into M. It's 1. Answer is 1. It's that easy. Okay? Alright. Now I'm gonna do something crazy. I'm asking, what is this?
Exactly what's written down there.
I mean, you mean this? These two?
Yeah, wouldn't that be exactly if you're shoving in the same thing that's already there?
Yeah. Yeah. But we are going to blend in both into messier equation. Okay. So yeah, X is going, I mean, just like act like the same thing. When you had a number, you put number in, right? Now you have a variable, you need to enter that X into P. Oh, this is already X entered into P. Just X and enter X in X then. And what is the result? As you said, it's the same thing, 1 over X plus 3 coming out of this thing. P turned X into 1 over X plus 3. We no longer have a number as a result, we have a variable result. Look, I applied X to P, X turned into, I applied X to X, it turned 1 over X plus 3 again. Nothing happened. Now 1 over X plus 3 is going into, this is interesting now, this is crazy. 1 over X plus 3 is gonna visit M. Okay? So what is the formula of M? I'm gonna take M here. If X, single X, visit M, it turns into X cubed. But who's visiting M now? It's no longer X. 1 over X plus 3 is visiting it. So guess what you're gonna supply in X? You're gonna take an eraser, remove X anymore because somebody is coming in and replacing all X's. Erase it and replace what? Put here 1 over X plus 3. Since it's multiple terms with a ratio, put the parentheses around it. That's it. You found that 1 over X plus 3 cubed. Okay? Now, let's do the work you did here. What was the first question we did? Mop X, right? This is mop -2. You did -2, right? Look how fast I can do it now. Map -2 is, plug in -2 here, that's 1. Look. If you get a formula with x's, if you see -2 here, I will make -2 there. 1 over -2 plus 3 is 1. 1 cube is 1. So I can get to the result faster if I have already pre-built composition function for us. Otherwise, you have to do all of this work manually. Send number in, send it again, and compute. Send number in, send it again, compute. Every time you need to do double work. But if you have one formula ready, you can do it anytime you wish. You can now do -5, you can do 10, 100. So all you need to do is substitute those numbers here. Okay? Okay? But that was something more than what's requested here. I think one of the questions requires some kind of work like that. Yeah, this one, for example, x, you see x is going into G, and G is entirely going into F. So who can write me the answer? Look, x is going into G first, and that comes out as this thing, and it's going directly into F. G is going into F later. X went in, turned into this, and this is going and replacing all x's in F. The answer is, anyone?
X squared plus 7x plus 4.
Yep. Again, how did I get it? For those who needs more explanation, it's asked to find f of gx here. I first send x into G. It's already been sent here. If x is sent into G, what comes out is 4x squared plus 7. So 4x squared plus 7 is going into F. Now take the F formula here, because if x is going in, this is coming out, but it's not x is going in anymore. Who's going in? 4x squared plus 7 going in. So you need to empty all the spot with x's. So this is actually x plus 4. We start with x plus 4, but you need to erase x, because no longer x is going in. 4x squared plus 7 is going in, and make this 4x squared plus 7 x. 4x squared plus 7x. It's 7x. So the answer is 4x squared 7x plus 4. Just basic replacement. If x is replaced by something more complicated, each and every x on the right side must be replaced as well. Okay. Next question.
Some question for geographic.
Where is it?
What we just did.
So you want to do g of f?
Yeah.
You want to flip the direction? Okay.
Yeah.
So next question was, how do you do if g and f flipped? This time x is first visiting f. Look, x is going into f. What happens if x is going into f? It turns into x plus 4. So it will come out as x plus 4. X plus 4 is going into G now. So let's do that. Make every x here x plus 4. This is going to be x plus 4. That's going to be x plus 4. Look, f is shooting out x plus 4 after production, and G machine is taking in x plus 4. That means each and every x will become x plus 4. So this is it, 4 times x plus 4 squared 7 times x plus 4. This is acceptable, but if you want to continue, you need to FOIL this square, like x plus 4 times x plus 4, and distribute this. If you want to continue, this is optional. Combine like terms and numbers, etc. But this is fine. Again, for further work, if you wish to, you need to do this. I will FOIL this as x squared plus 4x 16. That becomes 8x, and then I will multiply 4 with each. And combine like terms. These are like, these are like, and we will get 4x squared plus 39x plus 92. Okay? That's the details if you wish to do it. Alright, next. Saving people from prison. So about this question. You just need to find out whether these are numbers computable or not.
Let's see, yes, no, no, yes, yes.
Hmm?
Isn't it, yes, yes, no, no, yes, yes.
Let's check. Is not. You said is not?
Yeah.
Yes, yes. I think so. Right. But why?
Something with the sentences, isn't it?
It's all about the jail type, even index, right? Yeah. Look, this power does not cover the minus. Yeah, it has something to do with parentheses. It does not cover minus, so when you're building your jail with this power, minus will be left out. How do you build your jail? 4 goes out, 3 goes in, about 16. If you have a negative power, that means it's reciprocal of this. Okay? And minus will be out here. Well, can you compute such a thing? What is the criteria? You can compute even index radicals only if you have a positive number inside. This is a positive number, even index, I can compute it. There is no problem with odd indexes. If you have an odd number in the guard, you can compute negative or positive, everything. But all these questions have even index. So this is a yes. This is a yes as well. Because if this is positive, you won't have reciprocal on it, this whole thing. So this is a yes. This is a no. Because when you change this into prison, 4 comes out, 3 is in, but minus 16 cube is a negative number. You cannot compute fourth index of negative numbers. Try to do that, for example. Multiply this 3 times with a calculator. Try to take fourth index radical of that. It will give you an error. This is no. Same deal for this one. This is 1 over fourth index negative 16 cube. I don't care it's 1 over or not. Same reason. This thing is not computable. This thing is not computable. And this is yes. Although you have a negative sign on the top, we are okay with that. We can flip it into positive like this. And 3/4 turns into positive number inside. So we are fine on this one. And this is already fine. This is fourth index 16 cube. 4 comes out, 3 it stays in. Okay? Any questions? Let's ask in the next step. Oh, they want us to compute this literally. And yeah, you have to continue from here and compute them. 16 cube is actually, you can break 16 more into 4, actually 2 as well. 16 has secret quadruple 2's in it. There are 4 2's stacked inside 16 and you are cubing it, and that means when you multiply these two, join this, it is 12. But the guard wants $4. There are 12 2's. How many 2's can you save from this prism? Guard wants 4. 4 goes into 12 3 times and nothing left. So that means all 2's out, all out. But you will have only $3 above 2 on power 2. $3. So it's 2 cubed the answer. 12 over 4 is 3. 2 cubed. Which is minus 1 over 8. Okay? That's what we're gonna enter here. Or you can turn that into decimal, which is not necessary. Alright, what's the trick on this one? You no longer have a fraction on this because it's positive power. It's not a fraction. So you need to flip this. There is no fraction anymore, but you still have the minus sign. So it's minus 8 the answer. You're going to repeat everything here for this question, but only no numerator 1, no denominators, etc. When you do this again, it's 2 to the 12, fourth index, that is minus 2 cubed. Minus 2 cubed is minus 8. This one will be minus 8. There was only 2 computable here. No, that 4, right? So we need to do 16 raised to the power minus 3/4. Well, negative, and you already compute negative of it. This is positive, so you just cheat from part 2. This is gonna be positive 1 over 8. The only thing missing is minus sign, so this should be positive. Again, this one here is just positive of it. It's just gonna be 8. But does it hurt if you redo this all from scratch, 16, 3 to 4, change it to radical, and then save people out? Yeah, you can do that. It's gonna be the same thing. Okay. So I'm doing fast because these are all done in class. So all videos are uploaded. So if you hesitate, still wanna see these in detail, watch the proper section. Look, 10.2. Go to Carmen, find that section video, watch it. Okay? Alright. Again, all the questions have a sample solution in class sessions. You just need to go look up them and make sure. I mean, the reason I put this, set up this practice problem, we already solved them in class. Why did I set up? Because this is a good exam medium. You can just, like you're in the exam, skip one question, like 30 questions, skip always one, do 15 first, see if you can do it in 1 hour, finish it in 1 hour and see what you get your score without watching any videos, without checking your notes, if you can score 90% or more. If not, go study more and solve the other half again and see if you can still score 90. Alright, so again, you need to practice. Practice. That's why you're in this section. You already know this material before coming to this class. You just need practice.